Just notice the opening of the videos all look pretty much the same here. So I'm going to hit the space bar, and under our orientation we have the standard views again. We don't really have a need to split the screens. We have a normal too, but then in the upper right corner here I can go to dimetric or trimetric, which just kind of shifts the position. Alright, so I can also hold down the middle mouse button, rotate this a little closer to position, and I need to know the order that we're going to assemble. So we have the crank on the left side, the coupler on the middle, and the follower on the I say right side, left side, right side. Okay, on that side. So we need to bring a component in. It's not currently loaded, so we're going to browse to our folder, and we're going to bring the crank in first. And I can just rough position it. It doesn't really matter which side it's symmetric. And as far as orientation, it's pretty close there. So with our 6 degrees of freedom, I do want this to rotate. But there may be a location, something that I would want to set this up as a mate, just so it doesn't move unexpectedly. Alright, so I've already selected my cylinder. I'm holding down the control button and selecting another cylinder, and we'll go right into concentric. Alright, this is going to be the fastest way to apply the mates. Alright, so that goes into position, but it's still able to move back and forth. So I'm just left clicking, holding down on the face, and as I move the mouse it's going to move the part. So I've clicked the inside face, holding down the control button again, and we'll make that coincident. So we're doing a lot of coincident, a lot of concentric. Anytime you have planar faces, you're going to be doing coincident. Anytime you have those cylinders, they're going to be concentric. Alright, so in this case I do want this to be able to rotate. I don't really know what's down here, what the rest of the assembly looks like, if this is going to run into something or if there's issues, but that gives us a good start. So the next item would be the pin, if I'm going in order here, thinking about how this would assemble. It doesn't necessarily have to be the pin, but because of that flange, because of the flange, I'm going to need that as a space or a location. If I were to just take the coupler and put it right up against the crank, then I wouldn't be leaving the room for the pin. All right, and of course, if it's on this side, it's going to run into the base. So let's go ahead and insert a component, and then browse. We'll pull the pin short in, and its orientation, not so much. So if I look down at the reference triad, let's rotate about X because it's symmetrical. Doesn't really matter, and we can go ahead and place it. I'm just going, rough position as we rotate. I got it pretty close. Didn't throw it off into space anywhere or do anything strange, so we'll call that good. Alright, so previously we did the select and control select. Let's do the paper clip this time. So we go up to the mate relations, and as long as the blue box, I don't have to hold anything down on the keyboard. So I'm going to pick my cylinders, and that's going to allow it to go to concentric. Again, the pop-up is going to be in there. Rotation, well, it's still going to rotate with the part. We haven't really done a motion analysis or what we want to be the bearing surfaces and the press surface, those types of things. So we're going to hold off on that and let it do its thing, observe the motion, and see what we can come up with. All right, so once I picked a strategy, I'm going to kind of stay with it. And that inside face, rotate around, go to the other inside face, and hit OK. Now, because these are planar, they're the same dimension, I could have picked that face, but if I change that dimension, if the crank gets a little thicker, a little thinner, then the flange isn't really going to follow it, and I may end up with an error since that is the seating surface. When we press that in or put it into the crank, it's that's the point of contact. All right, so we're going to let that rotate. So now I have thought I located that one. So let's see what's oh, we have the other concentric. Not exactly sure why it would cause that one to go underdefined, but I'm okay with that. We'll see what happens to the other one. All right, so I'm always doing kind of this running tally as we go through the process of look over to the left. That one was defined, now it's not. Not sure why. Does it hurt anything? In this case, no. So we'll just go on to the next one. Insert component, browse, and now we're looking for the coupler, which is the long one. And we bring it in rough position. Orientation is okay. And now to locate it, we're going to go through the same process. Cylinders. Let's see, we need another way. So if you're comfortable with the select and control select, stay with it. If you're comfortable with picking the mate, relations paperclip, stay with it. And then I'm going to introduce the S key. So S on the keyboard, and that will take me to the paperclip. And since I'm in the blue box, I don't really need to go over and do anything. I'm just ready to pick. So again, the advantages of the property, the mate properties, is that I don't have to hold down the control button on the keyboard. All right, so the pop-up, we're at concentric. If I don't recognize the type of mate that it is, hover over top of the button, or look over to the left and it will give you the text. Okay, so we go ahead and hit OK. Staying with my strategy for the coincident, pick the face, rotate over, and then the middle mouse wheel, wherever you're pointing with the arrow, that's what's going to zoom in. So if you have any difficulties picking face too far out, do not hesitate to zoom in and make sure that you can locate that geometry. Alright, so at this point, rotate a little bit more. If I go to move the crank, it's kind of staying in position, but if I wanted to, this can do all kinds of strange things. Alright, so Control 7 gets me back into an isometric view, and then we're going to insert another instance of the short pin. So hold down the control button. Last time I think I did it from the work area, grabbing onto the part. Here I'm going to grab instance 1, drag it in, get it pretty close, let go of the left mouse button, let go of the control button. Now I'm in position. Alright, so I'm going to go with the select control select. And concentric, and the mating seating face, control select, and coincident. So you're going to find that you're going to get into a rhythm with this, whichever method you prefer, and be able to generate those geometries. Alright, so let's say for a second that I forgot that I have a follower arm, and I grab a crank arm and I bring it back in. Oh, don't know what I clicked there, but I got something. And I go ahead and we're going to apply those mates. Concentric. Yeah, that got kind of lost, so if I left click and hold down, it did apply. Alright, so I got a coincident to the edge. Button happy, so occasionally we're going to get a little get that inferred geometry. So I want to delete the edge. It's on the base that doesn't help me, so I can just highlight it and hit delete on the keyboard. If you right click and clear selections, be careful with anything that says delete all or clear selections. Going to pick on the face. Cause mate errors. Do you want to avoid these? we'll let it go ahead and change. So it turned it around. I probably could have just picked the other side and it would have been fine. Alright, so let's rotate that up. That gets it into position. I have the appropriate gap. We're not quite lined up somewhere there. Oh, I started building out, so wasn't actually paying attention to what I was doing. So that's going to happen. If we go back into the pen, concentric is good. Sharing those centers is fine. My coincident is the one that has the problem. So just like here where I went back in and edited, whatever that was, I'm going to deselect the face on the coupler. Alright, so looking at that definition, I think the face for the pin's good, so the other one on the coupler is the one that I want to remove, and that was just highlighting it and hit the delete on the keyboard. Then I'm going to select the face, and go ahead and figure it out. And following mates were reversed. And okay, if it did not do that, and did not do it correctly, or did not give the desired result, then I would need to break or apply those mates manually. Alright, and then the last one is to control select and go concentric. Alright, so at this point I look down through my list, everything moves. Interesting. So something happened in the coupler in that mate. Concentric, coincident, concentric, coincident. Well, they're the same length, so maybe one of those isn't happy. Or the other crank, we have coincident, concentric, concentric. Alright, so at this point, let's try to replace that crank. So I realized that I made a mistake. I can always just right-click and delete it, and when I hit the delete button, it's going to remove it. But I also have the ability to, if we do the down arrow, replace components. So replace mate entities, replace components. I want to replace the component. So the crank instance 2, and we're going to browse to the follower. Okay. And no, I don't need the base. Not sure why the base is still in there. Okay, I'm going to make sure it's highlighted just in case. Alright, so it puts the follower in, and because it's similar geometry, because I actually did the save as and it should be the same geometry, it's going to find the coincident, it's going to find the concentric, it's going to find the concentric, and if any of those are incorrect or missing, we can always delete them, not apply them, go through and adjust accordingly. Alright, so now we have the follower. Let's see if that will rotate. Alright, so if that one's moving, well, we already said that's the follower, so there we go. So it can do some weird things. Let's go to the backside view, and as we're rotating this around, let's see if that will, so it can't stretch past that point, but when we come over here, it's making kind of that weird little jump. Alright, so we're going to get this where it looks halfway decent and call it a finished assembly.